Okay, if we want to set the spreader for evenness, to make sure we're spreading evenly, we need to know two things to start with. One is what bout width we're going to use, what tramline width, and of course the second one is what fertilizer we're going to use. Then once we know that, we actually have to use the manufacturer's resources to get the settings. These resources, traditionally, they were given in the calibration charts, but increasingly we're seeing them actually on mobile phone apps or on websites, and those are the resources that we need to use. Okay, so in terms of classifying the fertilizer, probably the first and most important thing to do is get the size distribution, and this simple sieve test here allows us to do that. We put the fertilizer above the top grid here, and we turn it and we shake, and we see how much of the fertilizer goes into the different size categories. So after shaking for a few minutes, we can then turn it up, and we can immediately get an indication of the different distribution of particle sizes within that fertilizer, and that's a key point in terms of setting the spreader. Okay, the two other characteristics you need to know are to get the density of the fertilizer, which you can do by weighing an actual known volume, and the final point is to actually get an indication of the strength of the particles by using a simple strength tester like this here, where we actually measure the force required to break a particle of fertilizer. So these three characteristics are then used to classify the fertilizer and to go to the manufacturer's resources to match up with the products that they have online or their instruction book. And that will then give us the settings for that particular quality of fertilizer. Okay, so the information on physical properties of the fertilizer can then be inputted into a website or an app, or indeed looked up in a manual. We put the density in the value here, a value of 1, which we measured. Our granule type was a rough granule, we select that. We need to put the information from the little sieve test in here, the proportions in each box. Just simply put in here matching the sizes that are there, and it tells us that it has actually a matching result. We go to the next step. We need to pick the fertilizer spreader from this manufacturer that we're trying to get the settings for. We need to pick the working width, which is 15 meters, forward speed, we'll say 12 kilometers, and we'll say a rate of 250 kilos per hectare. And then it gives us the actual settings. It tells us the inputs that we have, the machine type, veins, working width, and so on, but the key figure here is the width setting, this 1112 value, which gives us on a scale where to set on this particular model the drop point of fertilizer onto the disc. On other models, the information they may give you here is the vein settings, the particular disc to use, maybe the PTO speed, or indeed the angle of the hopper. It also gives us a rate setting here, but the key figure here for evenness for this model is the width setting, and all manufacturers use a similar fertilizer matching tool to give us the settings for the machine. As a final check for evenness, some manufacturers would suggest using a limited number of trays in key points of the actual bout width. So that's really just to check that the setting is correct. It's not a full test of evenness, and for that you have specific trays. They're a ½ meter by a ½ meter with dividers in them, and the fertilizer is simply from those trays, which represent that part of the pattern, is simply tipped into test tubes here, and we see that it's even across the bout width. But that's only some manufacturers who require that.